Hello guys. Excuse me. Oops, my battery. Let me just wait, guys. Okay. Campbell Nicholas,
Yes, sir.
Fiorillo David,
Here, sir.
Harris Solomon, Wayne Hart,
Here, sir.
Hostetler Williams,
Here, sir.
Levine Gage, Light Nathaniel,
Here.
Mustian Paul,
Here.
Rodriguez Nina,
Here, sir.
Taylor Ismail,
Here, sir.
Tyson Elias,
Here, sir.
Tyson.
I'm here, sir.
Okay, and Vyas Margi.
Here.
Okay. Okay, guys. So let's start. Sorry. Where is the screen I want to share with you? It's not here. Okay. Okay, guys. So yesterday we went over what I want somebody to revise the things what we did yesterday very briefly. Yes, any one of you, please.
I believe we did a lot of rate of change questions. We talked about proportionality. We did the example with bacteria. We also did a heat transfer question. And then the last thing we did was going over another rate of change where we had the salt water and the brine concentration solution and all that, and how it changed over time.
Good. So we just went over very briefly about the non-linear differential equation and the exact differential equation from the practice test, and then after we went over the population growth problems, and then after Newton's law of cooling or heating problem with some chemical population growth problem with some chemical reaction problem, then Newton's law of cooling and heating problem, d of capital T over dt equal to T minus Tm, K times T minus Tm. Tm is the surrounding temperature, which is always constant, and K is the proportionality constant. And then after we went through the chemical mixture problem, right? And I told you that is always converted to the linear differential equation. And today we are going to start the electrical network problem from the first packet, example number 13. Nathan Light, will you please read the problem for me, example 13?
Yes, I will.
Yes. Keep your canvas open. I told you yesterday, all of you, please don't waste your and my time, please.
Question 13.
Question 13.
A 12-volt battery is connected to a series circuit in which the inductance is 1/2 Henry and the resistance. Wait, what? This is 1/2 Henry. And determine the current I of t if the initial current is 0.
Okay, guys. So you can see over here, $12-volt battery. So whenever you are asked the electrical network question, at that time, first of all, you need to go through the figure. So first of all, draw the picture like this. This is the battery. And then after, this one is the inductance. Usually we represent like this. Inductance is given to you, that is the 1/2 Henry. And then after, resistance is given like this, that is the 10 ohm. And that again goes to the battery. And whenever there is no, suppose battery is off, that means no current is passing through the circuit. No current is passing through the circuit. And that's why when I at 0 equal to 0, that's the initial condition, right? Now just look at over here. This is the closed loop circuit. That means you can use Kirchhoff's first and second law. Kirchhoff's second law says that whenever Kirchhoff's first law says that current I1, if you divide your current I1 in terms of I2 and I3, you can write I equal to I2 plus I3, something like that, which we are not using in this particular electrical network system. We are going to use that thing probably in the next section. Okay. And the second Kirchhoff's law says that current passes through different components that is equal to total electromotive force. So current passes through the inductance L, that is given by L into di by dt, always L into di by dt. Those who are electrical and computer science major and physics major, they know this thing very well. And current passes through L is given by L into di by dt. And then current passes through resistance is given by R times I, and then current goes to the inductance. So that is equal to E. So our equation will be L di by dt plus Ri equal to E. If you divide by this L, R, and E, you can see over here, these are constants. If you divide by L, you're going to get di by dt plus R over Li equal to E over L. That is equal to E over L. Okay. So this is nothing but the linear differential equation dy by dx plus py equal to q, where p and q are the functions of independent variable or constants. Here they are constants. That means I can go for the integrating factor e to the power p is p dx or p dt here. So r by L dt. R by L is constant, pull it out, so RT by L. So I times e to the power RT by L equal to integration Q is E by L and integrating factor e to the power RT by L dt plus C. That is the general solution for a linear differential equation. E by L is constant, again pull it out, and e to the power 2t, R by L, you can consider just like 2t, that is integration is e to the power 2t divided by 2. So here it is power RTL divided by L divided by R by L, just like this. Or you can say R by L equal to U, your choice. That means I'm getting this R by L, I can take in the numerator, so it is L by R, and LL will get cancelled out, so it is E by R, E by R, e to the power RT by L plus C. If you divide by this number, in that case, e to the power RT by L, this will get cancelled out, this will get cancelled out. Here it is e to the power negative RT by L. E to the power negative RT by L. Right? So I'm getting IT equal to E by R plus C e to the power negative RT by L. Whenever you are asked to solve the electrical network system, this system is called the LR circuit, because inductance and resistance, only two components are there. There is no capacitor. Capacitor usually converts your equation to second order. We are going to learn the capacitor and all these things in application of chapter 5, higher order differential equation. But here capacitor is not there. And if capacitor is there and you don't know how to solve higher order differential equation, you can convert to the current I, first order like this by some substitution. I will let you know. But here this is simply LR circuit. Whenever you are asked LR circuit, without looking at any of the data given to you, just go through all this stuff, this figure, all this stuff up to here. And then after initial, there is no current. So if you write T equal to 0, IT equal to 0, E by R plus C. So C equal to negative E by R. And just plug it back. So E by R is common, 1 minus e to the power negative RT by L. So up to here you have to go. Just write down the whole page whenever you are working with just LR circuit. And then plug the values given to you in the circuit. You are given E equal to 12, R equal to 10, e to the power negative R. Just plug the values. So IT equal to, this is 1.2, this is 1.2. 1 minus e to the power negative RT by L. Now, if you take suppose T equal to 5 seconds, that means how much current will pass through a circuit in 5 seconds? How much current will pass through a circuit in 1 minute? How much current will pass through a circuit in 50 seconds, like this? So different time will give you the different currents. I mean, it's a different amount of current, different volt of current in the circuit. Are you getting me? So this type of differential equation can also be solved using the different, this type of practical problem that can also be solved using the differential equation. Does it make sense? Any doubt in this first example, guys?
No, sir.
All of you are good?
Yes, sir.
Okay. Example number 14. Here I have a capacitor, but again, if you want to write if you want to install, if you want to have your capacitor in the circuit, in that case, usually capacitor converts your equation in the second order form. But here it is a little bit different, and I will let you know. Example number 14, I have solved over 13, I have solved over here. 14 and 15, or 14 is just similar, 14, 15. So please do it in homework. It's exactly like this. Come up to here and then after change your, and plug your values. Example number 16. Who wants to read this one? Nick?
All right, sir. 16. A 100-volt electromotive force is applied to an RC series circuit in which the resistance is 200 ohms and the capacitance is 10 to the negative 4 farads. Find the charge Q of T on the capacitor if Q of 0 equals 0. Find the current I of T.
Okay. So again, it is, now you can see over here, inductance is not given, but you are given the resistance in the capacitor. Capacitor is given in terms of farad, so 10 to the power negative farad, very small, 0.0001. Current IT, you have to show the direction also like this. Current moves like this, goes to the resistors, different components. So again, Kirchhoff's second law. Current passes through capacitor is given by always Q over C, or you can say 1 over C times Q. So what do you mean by this Q and I? What is the relationship between Q and I? Because we have two variables over here. One is I current and another is Q. You cannot work with two variables, two dependent variables, right? Because you know how to solve the differential equations just with respect to the one variable. Here it is with respect to time t. I is with respect to time t. Q is also with respect to time t. That means we have to convert either I is in terms of Q or Q is in terms of I. Q is in terms of I. Good. Now look at here. The relationship between this Q is called Coulomb. Relationship between the current I and the Q Coulomb is given by I equal to dq by dt. I equal to dq by dt. Again, physics law, Kirchhoff's law, current passes through capacitor is given by Q over C. Current passes through resistance is given by Ri, and that is equal to ET. So I is dq by dt. So let me convert this I to dq by dt. So R times dq by dt equal to 1 over C times Q equal to E. That is equal to E. Right, guys? That is equal to E. This is one way of representing your equation. Please listen to me carefully now. Listen to me carefully. I have converted my equation over here in terms of the Coulomb Q. And that's why I have first order. Look at what first order, first degree throughout. And I can solve this example very easily. But suppose somebody says that, no, I want to solve this one in terms of I. Is it possible? Yes. Ri as it is. This Q is, see, I don't have Q. I have just Q, but I don't have any relation. I have dq by dt. To use this equation over here, I have to take the derivative throughout. If I take the derivative, it is R constant di by dt. Di by dt. 1 over C constant dq by dt. Right? Dq by dt. And dq by dt is nothing but my, you can see what dq by dt, that is nothing but my I. Right, guys? So it is my I, and derivative constant is 0. So that is the other way of conversion, your differential equation. Anyway, right now I have converted this one in terms of Q. So R dq by dt plus 1 over C Q equal to E. If you divide by R, non-zero constant, you get look at over here. So there is 1 over RCQ E by R. Again, linear differential equation P and Q. So e to the power integration 1 over RC dt. Integration e to the power negative as e to the power t time t over RC. And general solution is Q times your dependent variable Q times integrating factor equal to integration right hand side E over R times integrating factor dt plus C. General formula. E by R constant, integration e to the power t over RC is t over RC divided by 1 over RC. Right? Otherwise, you can take 1 over RC equal to U, and you will get this thing. You will get this thing. E to the power t over RC equal to this 1 over RC can be written over here in the numerator as R times C. RR will get cancelled out. So CR or CE or EC e to the power T divided by RC plus C. QT equal to EC plus C e to the power negative T over RC. Negative T over RC. Initially, again, just like current, when I equal to 0, of course, Q equal to 0. So initially, Q at 0 equal to 0. So this is 0, EC, C e to the power negative R over negative T over RC. Right, guys? Because T equal to 0, this is 1. So C equal to negative EC. Just plug it back over here. So EC common 1 minus e to the power negative T over RC. And now what are the things provided to you? That E is 100, C is negative 10 to the power 4. That is, yeah, Faraday, and 1 minus this one. So just plug these values and finally you're going to get the answer is 0.01 Coulomb. Your example number 17 is exactly parallel to example number 16. So just please do this thing. Example 17 is parallel to example 16. And example 15, just for your convenience, I solved this example over here. But I will not ask you this example in the exam. Just solve this example, try to convince yourself, write it down in as your homework. I want this example in the homework, but I'm not going to ask you this thing in the exam, don't worry. It's not hard, only thing is some typical integration. This is E, this is E0. So di by dt is equal to, if you divide by L, E by L sine omega t. E equal to E0 sine omega t is given to you. E0 is constant sine omega t. This is a function of independent variable, so this part is a linear. This is a linear differential equation. Integrating factor is e to the power RT by L. And the general solution, just by using the linear problem, general solution is this one. Q is this one. Integrating factor dt plus C. Question only is how to get this integral. E0 by L is constant, pull it out. E to the power RT by L sine omega t dt plus C. This is the integral of the form e to the power at. A is R by L. E to the power at sine bt dt. There is a standard formation for this type of integral. Look at this arrow. Look at this arrow. Standard formation is like this. E to the power at sine bt is given by e to the power at divided by a square plus b square, a sine bt plus b cosine bt. E to the power at cosine bt dt is e to the power at a square plus b square, a cosine bt minus b sine bt. So these are two formulae. Just keep in mind this thing. Otherwise, you can write down both of these formulae in your formula sheet, integration derivative formula sheet, very first page, bottom part. You can write down these two formulae so that you can use these two formulae in your exam if it is required. Are you getting me, guys?
Yes, sir. Yes, sir.
Okay. So if you plug that value over here, and this is your A, this is your B, e to the power at over a square plus b square, and a sine omega t plus a sine bt plus b sine b cosine bt. I just plug the formula, and then after I just separated out this thing. I use simple calculation, LCM, LL will get cancelled out, and this is nothing but the answer. Look at here. This is the answer. Okay, last example, packet 1, last example 17. Again, it is exactly same as I told you. Actually, these are the homework, but I just solved for you. This 15 and 17. I told you, example 17, that is in homework. Look at here. But I solved for you. So this is the example number 17 and it's the solution. Please try to go through this one. It is exactly same as your example number 16. And everything is done over here. So that is the end of packet 1. And now we are going to start packet 2. So I request all you guys, please open your packet 2.
Sir, is packet number 2 nonlinear models and networks?
Right.
Okay.
I give both the packets in the beginning of this chapter in our file on the canvas. And the best thing is take the printout, just solve this example, then take the printout and solve all these examples with any of the materials. That is the best way to practice these examples. Anyway, it is your choice. But let's start with packet 2.
And the second packet isn't what we have to complete before tomorrow, right?
Yes.
Okay.
Packet 1 and 2 both due tomorrow. If you need some more time, I don't mind. I can open the canvas to submit your packets, not by tomorrow, by day after tomorrow. You want some more time?
You said packet 1 and 2 are due tomorrow?
Say again?
Packet 1 and 2 are due tomorrow.
Yes. Actually,
And the practice test.
both of them, they're due tomorrow, but if you need some more time, I can give you some more time and you can submit by day after tomorrow. What?
Can we do that?
Yeah.
Yeah,
I'd like, yeah, the day after tomorrow would be better.
Okay. Okay, guys. Now look at here. Logistic growth problem. Solomon Harris, will you please read the first page?
All right, population dynamics. PFT denotes the size of the population at time t. The model for the exponential growth begins with the assumption that dp over dt equals kp, k greater than 0. This is not very accurate model for a population. Population is very large. Also, it is very hard to find true cases of exponential growth over long periods of time. The assumption that the rate at which a population grows or decreases is dependent only on the number p present. It can be stated as dp over dt equals pf of p.
Good. So dp by dt, this is called the autonomous differential equation. This is called a logistic function too. So dp by dt equal to p a minus bp. You know, in the beginning of this chapter, I gave you, we discussed this type of problem. Suppose somebody is infected by coronavirus or somebody is infected by flu, and he's the only guy, he is suffering, he is infected by flu. And if he comes to the campus, all other guys, they are good, but he is the only guy infected. That means when time t equal to 0, just one guy was infected. And then after in 5 days, suppose that is spreaded to the community. And suppose now instead of now 1, that guy, he spread the same virus to 50 more guys. So in 4 days. So suppose in 4 days, 50 guys are infected, right? So what will happen? What will be the situation after 10 days? Using differential equation, we can have this type of scenario so that we can have some arrangement before the situation is getting worse. We can take some precautions. We can call the doctors on the post. We can do some other precautions so that disease cannot be spreaded. We can go for vaccines for flu, and all the cadets are forced to take the vaccine. So this type of precautions we can take if we know the numbers, that what will be the situation in next 10 days or 12 days or 15 days like this. Same with coronavirus, right? What's going on right now. So in that case also we can use the differential equation. So this differential equation, mainly this logistic function that is being used for this type of problem, epidemic spread problem. Just turn the page and read the very first example. Nina, turn the page and read the very first example. First or second one, maybe. But turn the page, first page, backside.
Logistic growth. Suppose a student carrying the flu virus, that one?
Mm-hmm.
Okay. Suppose a student carrying the flu virus returns to an isolated college campus of 1,000 students. If it is assumed that the rate at which the virus spreads is proportional not only to the number X of infected students, but also to a number of students not infected, determine the number.
Wait. dx by dt is proportional to rate of change of x. What is your x? X is the number of infected students, right? At time.
Yes.
The number of infected students at time t, rate of change means growth. Number of infected students at time t is proportional to not only the infected students, but also the non-infected students. So x times how many students are there on the campus? 1,000. So 1,000 minus x are the non-infected students. So it is x times 1,000 minus x. Initially, as I told you, that when all you guys come to the campus and only one guy is infected, that means X at 0 equal to 1. After 4 days, 50 guys are infected. That's what it says, right? Rodriguez, go ahead.
Determine the number of infected students after 6 days if it is further observed that after 4 days, X of 4 equals 50.
Right, guys? So X of 4 equal to 50 is the initial condition. And if X of 6, after 6 days, how many students will be infected, right? And if you know this thing, this kind of things, this statistical data, that means you can take some precautions. So that way also, this is more important. Okay, so question is how to solve this logistic equation. Use the proportionality constant, divide this X and 1000 minus X like this. You have a product of two functions. One is X, another is 1000 minus X in the denominator. Whenever you have product of two functions in the denominator, and if you're looking for the integration, you don't have any other choice except the method of partial fraction. Agree? So after this step, just go back to the right side. 1 over X, 1000 minus X is A over X plus B over 1000 minus X. 1, A 1000 minus X plus BX. When X is equal to, right, I just took the LCM. When X is equal to 1000, this part is 0. So B equal to 1 over 1000. X equal to 0, this is it. Or you can take the LCM and AX and try to arrange your right side in the descending order of X. And you can find A and B. Different ways of finding A and B. I found my A is this one, B is this one. Just go back and plug the values of A and B over here. So I'm getting this one. I just took 1 over 1000 out. If you take 1 over 1000 out, 1 over X plus. So this product is now written in the form of A plus B form. A plus B. So that's what I did over here. 1 over 1000 and 1 over X minus 1 over, actually it is plus 1 over 1000 minus X. Why I did this thing, I will let you know. That is equal to KT plus C1. KT plus C1 because K integration of 1 with respect to T is T plus C1. Okay. 1 over X integration is ln X minus. Now 1000 minus X. What is the derivative of 1000 minus X? Alex, what is the derivative of 1000 minus X?
Derivative of 1000 minus X is just 1.
Oh my gosh.
Or negative 1.
Negative 1, right? So if I want, you know, I gave you one rule in the last chapter that this is fx and this is f dash x, derivative of the function. If I want to use ln, I have to have the derivative of denominator over here in the numerator. I told you this thing so many times. I had 1 over here, but if I multiply by negative 1 and let me keep this one negative, so this negative will become positive and I'm getting the same function. So let me just, I would say, divide and multiply it by negative like this. So this negative as it is, and because now I have a derivative of denominator over here in numerator, I can use ln function. Derivative of x is 1. I can use ln function over here. ln property, x divided by 1000 minus x. Again, ln and exponential, they are the inverse function of each other. Send this ln other side as an exponential function. So e to the power this plus this. 1000 constant, C1 constant, E constant. I would like to consider this one as C. So C e to the power 1000 kt. X equal to 1000 e to the power 1000 kt minus x. And x, this I would like to send this one to right side. So x plus x, and that is equal to this one because I'm looking for my xt. So let me collect all my x's on one side. And that's what I did. Let me take x common, and that is equal to this one, divide by this factor. So xt equal to this one. If you divide by, once you get this one, then after you can find e to the power 1000 kt here and here. Numerator, denominator with this plus sign. You can divide by this number just to make your expression more simpler or compact form. So 1000 C over, here it is e to the power 1000 kt, but nothing is there. So let me write negative because you are dividing throughout. So e to the power negative 1000 kt, and this will be plus C. So this is your xt. Now I'm going to use my first initial condition, x at 0 equal to 1, and then second. X at, because I have right now two constants. One is k and another is c. Agree? K and c. And two initial conditions will give me the values of these two constants. My first condition, x0 equal to 1. Only thing is, example is very easy. Only thing is little bit lengthy example. x0 equal to 1, when t equal to 0, value of the x is 1. So if you plug it over here, t equal to 0, this part is 0, so k will disappear. And you can find the value of c, 1 over 999. Just go back and plug that value over c over here, c here and c here. Means you are getting like xt equal to 1000 over 999 and this one, 199. right? If you take LCM over here, 999, so 1000 divided by 999 to the power this one plus 1, and common denominator gets cancelled out from the numerator and the denominator. So xt will appear in this form finally. So I found the value of c. I'm going to use second initial condition, x at 4 equal to 50, and try to figure it out the value of the another constant, because so many times I told you that initial conditions are useful to get the values of the constants. So when time t equal to 4, after 4 days, 50 students are infected. So xt equal to 50, t equal to 4. So 4000 k plus 1. Here it is 1000 here, or everything that is in both the numerators, they are in multiplication. So I can cancel this 0, 0 and 5, 25 is 100. So here it is 20 and here it is simply 1. Because I have 1 over here, I can send all this factor to the right side. So 999 e to the power 4000 k plus 1 equal to this 20. Let me send this 1 to other side, so it is 19. So now 19. Make sure we are looking for k. So now I have 19 over here. Let me divide by 999. If I divide by 999, I'm going to get like this. E to the power negative 4000 k equal to 19 over 999. This 19 over 999, and I want to remove this e because I'm looking for k. So I don't want my e over here. Without removing this e, I can't find my k. And that's why I'm taking the help of ln functions both the sides. ln function both the sides. So ln over here, ln and exponential functions inverse of each other will get cancelled out. Negative 4000 k equal to ln of this one. Use your calculator and you are getting negative 3.9623. So negative 4000 k equal to, of course, this is less than, less than 1. ln 1 is 0. So less than 1 is negative number. So negative 3.96. This negative will get cancelled out and you're getting positive number, because number of students infected after a few days will not be negative, right? It could be 0, but it won't be negative. Anyway, so if you divide by 4000 over here, you're going to get k equal to 0.00099. Use your calculator to get this number and go back and plug this value of k in your general form. xt over here, just plug the value of k over here. Just plug the value of k over here. So you're going to get xt. After finding both of your constants k and c, your equation will look like this one, xt equal to this one. Once you find both of these constants, only then you are allowed to answer the question which is asked to you. So what will happen after 6 days? So after 6 days, when t equal to 6, just replace your t by 6 throughout. You're going to get 275.52. Don't leave this one as the answer, guys. Please, you have to round this number, because you cannot cut the person, right? So there is no 275.5%. It has to be either 274 or 276. Am I right? So please round this number. If it is more than 0.5, just round it to next number, otherwise less than that one number. So 276 students. That means, see, in just first 4 days, 50 students were infected. But now these 50 students are also spreading the virus to the other community. And that's why number is increasing rapidly. So 276 students will be infected in 6 days. That means whatever the steps you want to take it right now to decrease the spreading of virus. Are you getting me, guys? Are you,
Yes, sir.
guys?
Yes, sir.
Any questions so far? Any questions so far?
Yes, sir.
Okay. Okay, good. Ismail, read the second question.
All right. The number N of T of supermarkets throughout the country that are using the computerized checkout system is described by the initial, by IVP,
Initial value problem.
by the initial value problem.
Yeah.
dn by dft equals n times 1 minus 0.0005 n. N of 0 equals 1. A. Use the phase portrait concept of section 2.1 to predict how many supermarkets are expected to adopt a new procedure over a long period of time. By hand, sketch a solution curve of the given initial value problem. Solve the initial value problem. How many companies are expected to adopt a new technology when t equals 10?
Right? When t equal to 10, how many companies are expected to adopt this new technology? And first of all, you need to go through the phase portrait, whatever we went through in article 2.1, last chapter, first article, right? For this logistic growth problem too, because logistic growth problem are also an autonomous differential equation problem. And that's why you can always go for the phase portrait, right guys? So phase portrait means whatever function you are having over here, your first derivative equate to 0, try to find the critical numbers, and that critical number will allow you to make the partition. And each of the partitions, you have to decide whether your function is increasing or decreasing. If one is decreasing and second one is increasing, that means your arrows are facing each other, means it is attractor. If the arrows are in the opposite direction, they are repeller. Attractor means asymptotically stable. Repeller means asymptotically unstable. That's what we mean by the phase portrait last chapter. Am I right, guys?
Yes, sir.
Yes, sir.
Good. So first of all, as I told you, phase portrait, this is my dp by dt equal to f of p. So here it is n, so f of n, that is equal to this one. Already derivative is there, means we are equating to 0 to find the critical number. So critical number. If you equate to 0, you're going to get n equal to 0, otherwise n equal to 1 over 0.0005 means 2000. So n equal to 0 and 2000 are the critical numbers. Two critical numbers, that means you will be having three phases. One is n equal to 0, n is equal to 0 over here. N equal to 2000, right? N equal to 2000. So 2 points. 2 points means we have two phases. One is over here, this phase, and second one is this phase. Choose one number from here. Suppose I choose 3000. If I choose 3000 and try to plug this value in my f of AB or f of B, and that is equal to my f of n here, that is equal to this one. If I choose the number 3000, n equal to 3000, my value will be negative. Look at here, my value will be fn equal to negative 1500, something like that. Means it's decreasing. Choose one number from this part. If I take, suppose, n equal to 500 or n equal to 1000, if you take n equal to 1000, your number is positive. Over here, your number is positive, means it is increasing. Increasing looks like this one, decreasing looks like this one. Arrows are approaching each other, and that's why it is asymptotically stable. Just like a revision, right, of your article 2.1. And first part of your problem is over. Second part of the problem, it says that find the solution. Exactly same as the last problem. Exactly same. dn over, look at here, this is my dn by dt equal to this one. Here it is n and here it is n. Let me take, instead of x, now I have n. That's the only problem. So take the whole part in the denominator and this dt on the other side. So it's kind of separable variable. Once the variables are separated, go for the integration. Here we have product of two functions in the denominator. Again, go for the method of partial fraction. Method of partial fraction I have done over here on your right side. So 1 over n times this one, a over n plus b over, because it's a linear factor. So a over n and b over this one. Find your a and b using this partial fraction method, calc 2. So if n equal to 0, this part will be 0, n equal to this one, yeah. So you're getting a equal to 1 and b equal to this one. Go back and plug these two values over here, 1 and 0.0005. Simplify this one, you're going to get 1 over n minus 1 over n minus 2000. So actually this 1 over n times 1 minus 0.0005 n is nothing but 1 over n minus this one. So just go back and plug that value here. And integration of 1 is t plus c1. Derivative of, integration of 1 over n is ln n. Derivative of n minus 2000 is simply 1, appears over here in numerator. So this also will go for the ln function. So integration of this part is ln of n minus 2000 and k plus c1. Property of ln says that ln of a minus b equal to ln of a minus ln of a minus ln of b equal to ln of a divided by b. That is equal to this one. If you want to cancel this ln, take exponential both sides. So e to the power t plus c1, e to the power c1 is one constant c to the power t, 1 over n, 1 minus 0.0005 n equal to a over n. Sorry, my bad. N equal to, this is just the matter of partial fraction. So n equal to this one. We are looking for n. Please don't forget. You are looking for n. So send this, multiply throughout by n minus 2000, both sides. So n equal to n minus 2000 like this. I have one n over here, so let me send this n to other side and take n common. So 1 minus c to the power t equal to this one, divide by this factor 1 minus c to the power t. So nt equal to negative 2000 c, because if I divide e to the power t here, here, and here, so it is e to the power negative t here. Initial condition n at 0 equal to 1. When t equal to 0, value is 1. And I am finding my value of c using this first initial condition. Value of c is negative 1 over 19999. Plug that value over here in this latest equation. Divide by 1999. Last time we divided by 999. Here it is 1999. So divide by this number, you are going to get this one. 2000 divided by, this is 1 here, plus sign here, and e to the power negative t, negative 1999. And now it says that there is no k over here. So now it says that what will be the situation, how many people are expected to use the new technology after 10 days. So after 10 days, you can see over here when t equal to 10, approximately 2200 sellers are expected to use the new technology. Look at here, guys. New technology. Don't say 21,999.62 because again, it is counted in the integers, positive integers. So you have to give the answer which makes sense related to the given problem, which makes sense given to the related problem. So please be careful. Okay, example number 1, 2, 3, 4, 5. They are just similar to each other. Example 1, 2, and 3. 1 and 2 I solved. Number 3 is just similar, so please solve it. Number 4, I don't want to solve it right now. Number 4 is a radioactive substance. I don't want to solve that problem right now. Right now, let me go through the electrical network system. Few more examples in which your capacitor is directly included. Right, guys? So, number 6. Who wants to take number 6? I want somebody to speak the example. Yes, any one of you want to take the initiative? Number 6.
I've got it, sir.
Yes.
Show that a system of differential equations that describes the currents I2 of t and I3 of t and the electrical network shown in the figure is L of DF2 over dt plus L times di3 over dt plus R1 times I2 equals E of t. And negative R1 times di2 over dt plus R2 times di3 over dt plus 1 over c times I3 equals 0.
Okay, guys, look at here. This figure will be provided to us. This figure is provided to us. And we want to set up those two equations. So those two equations, these are our answers. We have to use this figure such that we must get those two equations. We must get those two differential equations. Right, guys? So whatever two equations provided to you, that's just the answer. That's not the That's not any kind of information. So you can't use those equations. You are supposed to get these two equations using this figure. Are you getting me? Are
Yes,
you
sir.
getting me, guys?
Yes, sir.
Any
Yes,
doubt?
sir.
Else? Any doubt?
No.
Yes, sir.
Okay. Nina?
No, sir.
Okay. Look at here, guys. Please pay your full attention. So many people are losing their points over here. My figure is given like this. Battery is there. One inductance is here. Then my current I1 is divided into two parts. One is I2 and here it is I3. Here I have another resistance that is called, one resistance R1 and second resistance here is R2. This is my closed loop circuit, but it has two closed loops. One is this one, second one is this one. Here I1, L goes like this, goes like this, goes like this, goes like this, and goes like this. That is my first loop. My second loop, it goes like this, goes over here, current I3 passes through resistance R2 and capacitor C, goes like this, and like this, and goes to the battery. So first of all, I would say that, let me give the name A, B, C, D, E, F, like this. Actually, I gave the name C over here. I request you don't give name C here. That's wrong, actually. It's not wrong, but you know, this C is capacitor. C stands for capacitor, and you are giving C as one constant point. Don't do this thing. Otherwise, you will get confused between these 2 points. You can say C1 here. This capacitor C will remain as it is. Just you can say C1, or you can say A, B, D, E, F, G. Just say like this. It's up to you, your choice. But don't say C, it's C1, something like that. Okay, let me work with the first loop. You have to mention your loop. Here we are going to use both the Kirchhoff rules. Current I1 is divided into 2 parts. So I1 equal to I2 plus I3. That is my first Kirchhoff's law. Kirchhoff's first law. I1 equal to I2 plus I3. Now I would like to consider my first loop. First loop is A, B, E, F, A. Loop means it has to be a closed like this. A, B, E, F, A. Right? A, B, E, F, A. In this loop, current passes through inductance is L into di by dt. Agree? Current passes through inductance is L into di by dt. Am I right, guys? Look at here. It is like this. Are you getting me, guys? Let me just wait 1 minute. L into di by dt. Look at here. Yes or no?
Yes, sir.
But actually my current is not, see, I write di by dt because my current usually in the previous examples, I assume my current was I of t. But here it is not I, it is I1. Can you see here? Can you see here? It is I1. So my current would not be just I, it is d1 by dt. Shall I write like this now? di1 by dt. All of you?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Got it.
Okay. Then my current passes through inductance R. Usually it is R times I, but here my current is not I or I1. It is now I2 and inductance is R1. So it is given by plus R1 times I1, I2. R1 times I2, look at here, R1 times I2, and then there is no component, so it goes to the battery. So that is equal to E. Shall I write like this? Shall I write like this?
Yes, sir. Makes sense.
Okay. Good. Now let's go for the second equation. So I have my first equation, Kirchhoff first law. Second equation I just got using my first loop. I am going to use my second loop. Again, second loop means current starts from the battery. Ismail, are you okay?
Yes, sir.
Current starts from the battery, goes to the inductance, so L into di1 by dt. L into di1 by dt, that is my first part. Then after it goes over here to the resistance R2, current associated with R2 or passes through R2 is I3. So I can write plus R3 I2. Try to pick up my words. Then after the I3 current passes through capacitor C. Current passes through capacitor is given by Q over C, right? And what is the relationship between Q and current? I equal to dq by dt. Agree, guys?
Yes, sir.
I equal to dq by dt. But here you cannot write I. Here you have to write I3. I3 is dq by dt. So I3 is your dq by dt. Am I right? And then after current goes back to the battery E. So that is equal to E. Shall I write like this? These are my equations now. Just try to focus on red lines, red bands. Clear? Clear?
Yes, sir.
All of you?
Yes, sir.
Okay. And now you're almost done. Look at here, guys. Kirchhoff's second law. This is my first loop. This is my second loop. You have to mention the loop like this. My second loop equation is like this. You have to mention like this, where your Q is associated with your current in the form of I3 equal to dq by d3. Now you have to play with these three equations, your 1, 2, and 3 equations, and try to set up the equations I gave it to you in the example. You have to use these three equations in such a way that you can get those two equations. So if I plug this value of I2 and I3 over here at I1 is replaced by I2 plus I3, I am getting my first equation. So I2 plus I3, separate it. So L di2 by dt, L di3 by d3 plus R1 I2 equal to ET. That is my first equation, what I gave it to you. So you are proving those two equations using the given circuit. Okay. Now, if you look at the second equation, if you want to prove the second equation, in second equation actually, In second equation actually, do you find any I1, di1? Look at the second equation in your canvas. Do you find current I1 in the second equation?
Yes.
Yep. Do you find current I1 in the second equation?
Yes. Wouldn't it be paired with?
Yes, you said yes. I'm wondering, is there any current I1 in the second equation? Look at the question, guys.
Yes, sir.
Yes?
I don't see any, sir. I see I2 and I3, but I don't see I1.
Correct.
You mean the equation that starts with negative R1?
Correct. So I1 is not there. Do you find I1 in the required equation? I'm asking all of you guys. Elias is absolutely right. There is no I1. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Right, Alex? There is no I1. No I1, that means I have to remove I1 from my equations to set up the second equation. How can I remove I1? If I focus on equation 2 and 3, and if I compare these two equations, because ET is there, so if I write this left-hand side equal to this left-hand side, because both the right sides are same. So this equal to this, and I can cancel di1 like this. See, so if I comparing 2 and 3, this di1, L di1, this will get cancelled because I don't want even inductance. So cancel this one, and inductance and di1 is removed. It's gone. What is left out? R1 I2 equal to R2 I3 plus Q over C. But now I'm over here. R1 I2 equal to R2 I3. But I don't want R1 I2. If you look at the equation, I want R1 di2 by dt. Agree? Look at the given equation. R1 di, I want a derivative. Take the derivative throughout. So if I take R1 di2 by dt, R2 di3 by d3 equal to dq by dt times 1 by c. But dq by d3 is equal to I3. Already we fixed over here. Look at here. By d3 is equal to I3. Are you getting me, guys?
Yes, sir.
All of you are getting me, girls.
Yes, sir.
Okay. So di2 by d3 is equal to this one. And that is nothing but negative R1. And now I don't want R1 di2. I want negative R1 di2. Just multiply throughout by negative sign. If you multiply by negative sign, negative of R1 di2 by dt plus R2 di3 by dt plus 1 over ci3 equal to 0. That is the required equation, second equation. And we are done. People are facing problems in this type of setting the equations. So if you have any doubt, you can ask me. I can give you a couple of minutes to look at this problem. I can give you a couple of minutes to look at the problem. Just look at the problems, try to convince yourself. If you have some doubt, we can discuss. Just look at this one, pay your full attention.
Sir, do you think you can scroll down to the end of the equation where we related it to the? Okay, yeah, right there. Thank you.
Mm-hmm. Done? Done?
Yes, sir. I'm good.
All of you?
Yes, sir.
Yes, sir.
Okay. question number 8. This question number 6. Question 7 is really very easy. Just try it. If you're not getting, let me know. I will prove it for you. Question number 8. Again, this circuit is given to us. 2 loops are there. Current I1 is bifurcated into 2 parts, I2 and I3. First equation is Kirchhoff's first law, I1 equal to I2 plus I3 in 2 parts. Second, for the closed loop circuit, you can give the name A, B, then D. Don't give E, A, B, D, F, G, H, something like that. In the loop of A, B, G, H, A, current passes through, inductance is L times di1 by dt. Agree? So I'm going to get L times di1 by dt. First of all, I1 equal to I2 plus I3, my first equation. Second equation, L into di1 by dt. Then it goes over here to the resistance plus R I2 equal to E or E of t. So my first loop will give us this equation. My first loop will give us this equation. My second loop, that is A, B, D, F, H, A. So again, it passes through L. So I can say L di1 by dt. Then it goes over here, passes through C. So I would say Q over C, where Q is nothing but I equal to dq by dt. But it's not I, it is I3. So I would say I3 equal to dq by dt. And then after it goes to the battery, so that is equal to ET. So this way I have 3 equations. Look at here. This way I have 3 equations. Agree? Agree?
Yes, sir.
Good. Now try to look at the things. What are you looking for? What is your first equation? Yes, any one of you, Margie? What is the first equation, if you want to say?
Like the first equation given on there?
Mm-hmm.
So it's L, there's a line going through. So it's di1 over dt plus ri, and then subscript 2 equals E of t.
That means whatever equation 2 is there, that is your first equation. So you are not doing anything with equation 2. Am I right? Equation 2 exactly as it is asked to you. So you are done with that first part. Agree?
Mm-hmm.
Yes, sir.
Okay, Margie, continue. What is the second part you are looking for?
Capital RC and then di subscript 2 over dt plus I subscript 2 minus I subscript 1 equals 0.
I'm sorry, will you please repeat again?
Yeah. Capital RC and then di subscript 2 over dt plus I subscript 2 minus I subscript 1 equals 0.
Okay. That means now you don't want that di1, L into di1 by dt. Am I right in the second equation? Same technique, guys. Look at here. Same technique. This is the block box which you're looking for, first equation. Comparing 2 and 3. Comparing 2 and 3 so that you can remove this part. So I just compared because ET and ET are same on right side. So I compared this one. This will get cancelled out. RI2 equal to QC. RI2 equal to QC. Right? But I want C times R. So let me just take this the other side. So C times R, C times R, I2 equal to Q. But I want actually di2 by dt. So let me take derivative throughout. So RC di2 by dt equal to dq by dt. And dq by dt is a derivative. That is nothing but I3 in the condition. Look at here. Second equation where I3 equal to dq by dt. So this dq by dt is replaced by I3. Send this I3 to the other side. And I think that's it. RC di2 by dt minus I3 equal to 0. But what is your I3? You are asked in terms of I1, I2. So you can again go back to I1 equal to I2 plus I3, where I3 equal to I1 minus I2. So replace your I3 by I1 minus I2, negative sign common, and that is 0. That is the answer. Agree?
Yes, sir.
Yes, sir.
Any doubt? Any doubt?
No, sir.
Okay. Question number 4. The last example left out. Question number 4. dq by dt equal to negative lambda 1. Just solve these examples. Look at this one. Solve these examples. I am not going to ask you this example in the exam, because that is very simple. Only length is little lengthy. dx by dt equal to negative lambda 1x. First equation. If you divide by x and dt other side, separable variable, so x equal to e to the power c e to the power lambda 1t. That's the solution. You are given initial condition x at 0 equal to x0. So c equal to x0. Go back. So first equation solution is xt equal to x0 e to the power negative lambda 1t. Negative 1 lambda 1t. That is the solution of the first equation. My second equation, that is dy by dt equal to lambda 1x minus x2y. Lambda 1x means x is a function of t, y is a function of t, independent variable. Whatever xt I found over here, just plug that xt back over here. Just plug this value of xt over here. If you plug this value of xt here, you're going to get x0 e to the power negative lambda 1t over here, minus lambda 2y, minus lambda 2y. But now your form is different. Previously it was separable variable. Now it is dy by dt. This is lambda 1 constant, x0 constant, e to the power negative lambda 1 constant, and t is a independent variable. So if you send this one to other side, lambda 2y. So you're going to get dy by dt plus lambda 2y equal to this one. This is my p, constant. This is my q, function of independent variable. So it's a linear differential equation. Use the linear technique and find the integrating factor e to the power lambda 2y, lambda 2t. Solution is dependent variable y. Look at the cursor. Dependent variable y multiplied by integrating factor equal to right hand side integration q lambda 1 x0 constant, pull it out, e to the power negative lambda 1t, and integrating factor e to the power lambda 2t dt plus c2. So lambda 1 x0 equal to e to the power lambda 2 minus lambda 1 t dt plus c2. So y e to the power lambda 2t equal to lambda 1 x0 into e to the power integration lambda 2 minus lambda 1t divided by lambda 2 minus lambda 1 plus c2. Yt equal to lambda 1 x0 lambda 2 minus lambda 1 and this one. Right, guys? Yt equal, if you divide by lambda 2t, you divide by this one. So lambda 2t, here it is lambda e to the power negative lambda 2t. So lambda 2t and negative lambda 2t will get cancelled out. Only negative lambda 1t is left out here. And c2 multiplied by e to the power negative lambda 2t. Lambda 2t. So lambda 1 x0, lambda 1 minus lambda 2 minus lambda 1 e to the power negative lambda 1t and this one. Here we are given the initial condition y at 0 equal to 0. So when t equal to 0, y 0 equal to 0. So this is 0. This is 0. Right? And then when t equal to 0, this is 1. This is 1. So I'm getting c2 equal to this one. Go back and plug this value of c2 over here in this equation. So we are getting yt. We are getting yt. So now yt equal to this one. Lambda 1 x0. This is my final yt. My third equation. Zt by dt equal to lambda 2y. look at here, guys. Each equation depends on the previous one, because if you look at that big part which I gave it to you, if you read that one, you will come to know this thing. Let me finish this example and then after we will read this one. So dz by dt equal to, because everything that is the substance that is depending on the other substance. dz by dt equal to lambda 2 y equal to this one. So just multiply this one by lambda 2. Constants, you can pull it out. Integration, dt other side, term by term integration, z at 0 equal to 0. Initial condition, which will give you the value of the constant C3 equal to 0. Once you get C3 equal to 0, just look at this arrow, go back and plug this value of C3 over here, and ZT is your final value. Since just one substance, whatever is remaining substance is working in the second part, and whatever is remaining over here that is working over here, and whenever nothing is left out, that is called the stable solution, stability. Okay, Nick, will you please read this example slowly? Nick Campbell.
Yes, sir. I just had to scroll up to it. Radioactive series. We assume that the rate of decay was proportional to the number A of T of nuclei of the substance present at time T. When a substance decays by radioactivity, it doesn't just transmute in one step into a stable substance, but the first substance decays into another radioactive substance, which in turn decays into a third substance, and so on. This process is called radioactive decay series. This process continues until a stable element is reached. Suppose that X of T, Y of T, and Z of T denote amounts of substances X, Y, and Z respectively remaining at time T. The decay in element X is described by dx over dt equals negative lambda 1x, whereas the rate at which the second element Y decays is dy by dt equals lambda 1x minus lambda 2y. Y is gaining atoms from the decay of X and at the same time losing atoms of its own decay. Since Z is a stable element, it is simply gaining atoms from the decay of element Y. dz by dt equals lambda 2y. Thus, dx by dt equals negative lambda 1x, dy by dt equals lambda 1x minus lambda 2y, and dz by dt equals lambda 2y. Find a solution of the above system of equations subject to the initial conditions x of 0 equals x naught, y of 0 equals 0, and z of 0 equals 0.
Right? So now if you read this one, that first dx by dt solution, initial condition, that radioactive decay, that's why it is called decay. Whatever substance is left out, you can use that one over here in the next one. And then we can solve this one. Then again, we are left out substance we are using in the next one. And finally, we get the stability. Right? But again, just solve this example. Example number 5 is just to set up this radioactive substance. Just set up three equations and you are done. You don't have to solve those 3 equations in example 5. That's the simplest one. I think you can do that thing. So tomorrow morning, you are taking your exam, right, guys? Yes or no?
Yes, sir.
Yes, sir.
Tomorrow morning, you are taking your exam, and let me close this file. And yeah. So if you have any doubt, Margie, did you check your Canvas yesterday?
I saw that you said I needed to upload it because I tried to upload it after class, but it was locked.
It is not locked. I gave.
But no, I uploaded it after you sent the comment on there.
Okay. Yeah, because
I don't know if my grade's on there. I haven't checked that.
Without exam, how can I write the grade? You submitted your homework, not the exam. If I have your exam, I can give you the grades. Without exam, how can I submit the grade?
Yeah, it's on there now.
It's all there right now?
Yeah.
Okay. Good.
So all 3, is it just the second packet that you said we can turn in Saturday, or is it all the homework, or what did you want tomorrow and what did you want Saturday?
I just want tomorrow exam and Saturday evening by 6, your homework, packet 1, packet 2, and question number 11 of first packet, I mean to say first test assignment, and question number 1 from practice test of chapter 2 and 3. You know, first examples, I just close the file, but if you look at your Canvas, our class notes, very first page, first example, there are some examples based on nonlinear and exact differential equations. So I want that one. I want the last example of your exact differential equation of your test 1, practice assignment 1. And I want these 2 packets. Make sense? Make sense?
Sir, so on this exam,
I can't hear you.
sir, so it's going to be exact differential equations, nonlinear differential equations, and then these application problems from the 2 packets is what's going to be on the exam.
Correct.
And then, so exam is tomorrow morning.
Tomorrow morning exam, and packets are due. Packets with those 2 questions. Question 11 from first assignment. Question first from second assignment. Before I started chapter 3, I gave you one assignment, practice assignment. So I want those 2 examples and 2 packets by Saturday 6 p.m. Make sense?
Oh, so you don't need to do the whole practice test because it was 1 page of a bunch of equations.
It's almost same. If you want to go through
Okay.
the practice test, or if you want to go through these 2 packets, they are equal. They are same.
Okay, so just do question 1 and then focus on the word problems.
Exactly.
Okay, thanks.
And guys, this time you have to be very particular. I'm not going to extend the time. Okay, once your exam is done, I can give you one more hour, but make sure you have to submit your exam as just 1 file on Canvas. Please make sure this thing, please. Right? Any question for me?
No, sir.
Work hard, guys. If you have some doubt, I can do one thing, because you guys are working hard today. I know it. And that's why tomorrow morning at 9:45, first 15 minutes, I will try to solve your doubts. Okay, just kind of revision. If you have some last minute questions, I will try my best to convince you. And then after I will give you the exam. Sounds good? Because your lesson is just 1 hour. So I would like to spend first 15-20 minutes or something like that before your test, and then after we will go for the exam. Okay? Yes or no, guys?
Sounds good, sir.
Yeah, last 2 exams will be, now onwards, we will be having all exams on Friday except your final. Because final, we have to follow the VMI schedule. But for internals, all your internals, means exam 2, 3, 4 on Fridays. Okay? So
Yes, sir.
if we discuss or not, but be prepared, be ready mentally that you are taking all your internal exams on Friday. Make sense? If something is wrong, I will let you know.
Sir.
Yes. Yes. Any doubt? Okay, guys, shall we stop here? Shall we stop here? Oh my gosh.
Yes, sir.
Yes.
Yes, sir.
Okay, guys. Thank you so much. Stay safe, stay healthy.
Have a good day, sir.
Have
a good day, sir.
If you have any questions, we will discuss. Yeah, keep your questions aside, and we will discuss those questions tomorrow morning before the test as a review session. Okay?
All right.
Sure.
Sounds good, sir.
No problem. Ismail Taylor, please work hard. Okay?
Yes, sir.
Good. Good.
Have a good day, sir.
You too.
Thank
Thank
you.
you.
Have a good
See you
day, sir.
tomorrow, sir.
See you tomorrow. Thank you, guys. Take care.